Hello, I'm Mrs. J, and welcome to my math class. So this is Math 1035, and we're just going to start off with a little bit review just to make sure you remember the basics before we start the course. So we start with polynomials. So when we're adding or subtracting polynomials and you have them in quantities, this would be two binomials. But in this case, we're subtracting. If we were adding, you can just drop the parentheses and add them. But when you're subtracting, you want to be careful. This negative, you can think of it as a -1, but it needs to distribute before you can combine. So when it's an addition, just combine. So distributing the negative, we have a -x minus 4. Now we have 4 terms. Terms are broken up by addition and subtraction signs. And when we combine those, these two are like terms, and then these two are like terms. So the first two, 2x minus x would be x. You can think of a 1 there when it's not 1. So 2 minus 1 is 1x. And then 3 minus 4 is a -1. Distributing, kind of like we did the -1, you take the whole term in front and multiply it times each term inside the parentheses. So 3x times x would be 3x squared, and 3x times 4 would be a positive 12x. So here we just had one term times a binomial. If we have a binomial times a binomial, you can do what we call FOIL. When you're FOILing, you multiply the first two, 2x times 2x, 4x squared. Then O is for the outside. 2x times 1 is 2x. I is for the inside. -6 times 2x is a -12x, and L is for the last two. -6 times 1 is a -6. Now in most cases when you're doing this, the two middle terms will be like terms, so you can combine them. This is not a like term because it's x squared, and these are only x to the first. So we have 4x squared, combining these two, a -10x minus 6. Put a different number here. Okay. So when you have a binomial and you're squaring it, or any quantity that you're squaring, you cannot go x squared plus 16. You have to take it and multiply it times itself. You cannot distribute that exponent unless it's all multiplication inside. So you actually have to take x plus 4 times x plus 4. And then you would FOIL it. X times x is x squared. And then the outside, 4x. The inside. And the last two terms. So I multiplied the first two, then the outside, the inside, and the last two. And then combine the two middle terms. when you're dividing, what you can do is factor the top and bottom and then reduce. So if we look at the top, they're both squared, so you can use the difference of squares. X minus 4 and x plus 4. So if you have two terms that are both squared and you're subtracting them, it will turn into, drop the squares, a minus b and a plus b. And so we use that formula on top. On the bottom, it won't factor because this is x to the first. But notice we can pull a 2 out of both of these. So we take a 2 here, we're left with x. And if we pull a 2 from here, we're left with a negative 4. The negative 4's cancel and leave x plus 4 over 2. When we're multiplying fractions, you can cancel as long as it's from top and bottom. So these two y's would cancel. This r will cancel with one of these and just leave 1. And the 4 and 8 will also reduce. But it has to be 1 from the bottom and 1 from the top. And so we can divide by 4 and get 2. So we have 2r. Or 2 times 3 is 6r. The rest canceled. And on the bottom, there's nothing left, so it would be a 1, which you don't have to show. When you're adding or subtracting fractions, you have to have a common denominator. In this one, we have a common denominator, but what you want to be careful of, this minus sign in front needs to distribute to both of those. So since we have the same denominator, we can put this all on the same fraction. But then when we distribute the negative, we have a negative x and plus 8. So notice the x's cancel. And we have 8 plus 8, or 16. Also in the review, we have some solving equations. So if we have when you want to solve an equation, you need to get the variable on one side and the constant on the other. And so we could, to move the variable over, subtract it to the other side. So it will cancel. And over here we have a negative 7x minus 3 equals 11. And then we're still trying to get the x by itself, so we can add the 3 to the other side. And negative 7x equals 14, and then divide by the negative 7 to get it by itself. Okay, besides the linear equations, which is when you have x to the first power, we also have x squared, or the second power. When it's the second power, it's quadratic. You need to have it set equal to 0 if it's not already set equal to 0. And then you can either factor it, complete the square, or quadratic formula to solve it. This one is factorable. The reason I know it's factorable because there's two numbers that when you multiply, you get a -10. Then when you add, you get 3. And you can only use this way unless you use trial and error when there's a 1 in front. But 5 times a -2 will give me a -10, and when we add it, I get a +3. So it will factor to those values. Setting each of those equal to 0. We get a -5 and a 2. And so there's two solutions. Now on this one, notice that there's only 2 terms instead of the 3. It will still factor, but I want to say if you use the quadratic formula, A is 3, B is -12, and since there's no constant, your C would be 0. But for factoring purposes, we still could pull out an X and a 3, because 3 goes into both numbers. If we pull out a 3x, we're taking one of these x's, so it only leaves an x, and we took the 3 out. -12, if we divide a 3 out, we have a -4, and we pulled that x out. Then you can set each quantity equal to 0. This one you need to divide by 3 to solve. And this one, just add the 4 to the other side. When you have degree 2, so the exponent, largest exponent is a 2, you usually have 2 solutions. If it's to the first, you have 1 solution. Okay, if we had something like this, the first thing you'd need to do is factor this one out. Because that way then you know what to multiply everything through by. And in this case, there's x minus 2's in all of them, and then there's this 2. So we want to multiply by 2 times x minus 2. Now 0, of course, is just going to be 0, but if there was another number there, you'd need to multiply it by it. So in the first one, the x minus 2's cancel. This isn't going to work out. And we're left with 6. Here the x minus 2's cancel and the 2's. So we're left with a minus 5. And here the x minus 2's cancel and we're left with plus 2. When all of your variables fall out, there's a no solution or all solutions. So what we need to do is calculate this and see if we get 0. 6 minus, we get 3. In this case, there's no solution. If we would have gotten 0 equals 0, there'd be infinitely many solutions. The other thing you need to make sure when you're solving and you have a fraction that you won't get 0 in the denominator. The only way we get 0, notice, is if x is 2. To find that, set your denominators equal to 0 and solve. And this one would also be x minus 2. You don't need to solve this. You could wait till you factor it. Okay. We will stop there. But that will do the first half of the review. Thank you. Stop. Stop. Come on. You want me to hurry up. Stop. Oh. Okay, start over. Well, you didn't say go. Right.
I did the head nod.
All right, stop and start.
What?
Come on, don't. No, stop it and start it. No, start it and stop it. No, start and stop it. Hurry up. No, cut it. I don't like you. Cut it.
3. No, we go.
No, I can't. These people don't even know me yet.
Now they will.